The last section in Chapter 1 is called Dimensional Analysis. Make sure you have a notebook and a pencil and maybe a calculator, and you can follow along with it. Write down 1.6 Dimensional Analysis at the top for this section. It's a systematic method to solve metric and English using conversions, and then when we get to Chapter 3 and 4 and all in the future, we'll use it to solve many different types of problems. It's a systematic way that allows you to keep units associated with numbers and then work them out at the end so you never lose anything. So here's an example problem using the system of dimensional analysis. Let's say that we had a human person that was 110 pounds and we were told to calculate their mass in kilograms. Well, in the back of the textbook on the last cover, you could look up how many grams there are in a pound, and that place in your textbook, just so everybody knows it exists, is right on the inside back cover. You can go to it on your digital book as the very back cover in the next page, and you can find the pressure, volume, temperature, mass, length, and energy conversion factors for many things. And there's our pound and grams one right there that I wrote down for you already. So step number 1 is to take the number and units of the substance that you're given, 110 pounds, and rewrite it way on the left-hand side of your paper. If you have lined notebook paper, start way on the left-hand side where that red line comes down, write down 110, keep the number of sig figs that you have, put down the units that you have, pounds. Then put a multiply sign and put a line. Put a nice long line right here and don't fill any part of it in right now. Next, take the units that you're given, pounds, and put it in a position where it would cancel on this line. Some people don't like it this way, and so they write a line underneath here and then just continue it all the way along so they know which thing is on the top of the fraction, or the conversion factor is what it's called, and what thing is on the bottom. In this case, take pounds and write it down here on the bottom. So put pounds right here because that's the unit I'm given, and I ultimately want those to cancel. Then take the new units that I have and put them on the top. Now, I'm not given a conversion factor between pounds and kilograms, but I am given a factor between pounds and grams. And I know that I can get from grams to kilograms pretty easily. And so I would put grams on the top as my new set of units. My desired unit goes on the top right here, and the units that I have in a position where they're going to cancel. Now take the numbers and fill them in. Notice I put the units in first. Put the units in first, then the number. So 453.6 goes on the top, and then 1 pound goes on the bottom. My pounds will ultimately end up canceling my pounds, and the grams will be on the top. Lastly, I'm told to find it in kilograms, and so now I need another conversion factor, and this one between grams and kilograms. So put another multiply sign, and then put another line, or just continue this line, that's okay. And then take the units of grams and put it in a position where it's going to cancel. So put grams right down here, and then take the units that you desire and put them on the top. So desired units always go in the place where they're not going to cancel, and then put the units that you have in a place where they are going to cancel. So notice that these two would cross off with one another. And becoming good at placing the units in their correct location are the ones that makes you good at it all. So practice this all the time of putting your units in a place where it's going to cancel. Well, grams and kilograms, if you're not sure how grams are related to kilograms, well, you can go look on your little metric prefix chart right here. Here's kilo, and then here's the base unit of gram. And I always say count from the small to the big unit, count by tens. 10, 100, 1,000. So there's 1,000 of the small unit and the large unit. The small unit, of course, is grams right here, so there's going to be 1,000 of these smaller units and one larger unit. So that's where you get your conversion factor from grams to kilograms. Try these on your calculator. 110 times 453 divided by 1,000. You should end up with about 52.20 kilograms. That's to 4 sig figs, because these had 4 sig figs in them right here, and that's our least number because remember, these have an infinite number of significant figures in them. Let's take a look at one example problem that uses multiple units. So here we have an example problem where a nitrogen molecule, its average speed in air at 25 degrees Celsius is about 515 meters per second. Well, how fast is that in miles per hour? Okay, so we have multiple units right here, meters per second, and we want to know what that is in miles per hour. So the first thing to do is take the units and the number that you're given and rewrite it way on the left-hand side of your paper, leaving lots of space. So write it way over here by the left-hand side where that red line comes down. Put meters on the top, seconds on the bottom, and then put a multiply sign, and then put a line. Nice long line right along here. And if you want to connect the line, that's absolutely great. All right, take the units that you have and put them in a position where you're going to cancel. Well, now you need to make a choice because you have meters going to miles and seconds going to hours. And it doesn't really matter which one you want to convert first, just as long as you deal with them both. I chose to deal with seconds and hours first. And so I took seconds, the units that I have, and put them in a position where it's going to cancel. And then I went to minutes first, seconds to minutes, because I knew there were 60 seconds in a minute. Couldn't quite think how many seconds there were in an hour. Maybe you can, and then you can skip the next step if you want. But I went then from minutes to hours, and so I put minutes in a position where it's going to cancel, and I put hours as my new set of units because I knew, once again, there were 60 minutes in an hour. Now, you could have all done that in one step, and you could have put 3,600 seconds in an hour if you wanted to, but it's okay to do multiple steps like this because you're going to end up with the same answer. Notice how my seconds cancel with my seconds, my minutes cancels with my minutes, and right now, if I stopped, I'd have meters per hour, or meters over hour. I'm getting close. I've got hours right here, but now I've got to get meters to miles. So if you don't know how many meters there are in a mile, you can certainly look in the back of your textbook. There's a relationship between meters and miles right here. I looked it up for you already, though. And so this next step is to take a multiply sign, put a line right here, and then on the top, take the units that you desire, and I desire mile, and put those. Take the units that you have and put those in a position where it's going to cancel. Notice, even though we have this big, long chain of lots of calculations, even though meter's way over here, I can still cancel it with the meter over here. Some people put parentheses around here to kind of keep them all straight, and each one of these sets of parentheses is called a conversion factor, a piece that helps convert from one thing to another. Well, there happens to be 1,609 meters in a mile, and so I put 1,609 with the meters and 1 with the mile. On your calculator, 515 times 60 times 60 divided by 1,609. Hit equal sign in between all of those, and you end up with, in scientific notation, 1.15 times 10 to the third miles per hour. We'll come back with one more problem in the next video that involves cubed units and squared units.